something which is at the forefront of robotics technology, something that has baffled scientists for ages. I present to you Fonzie, the dancing robot. Music, please.
When I walk on by, girls be looking like they be fly. I pick to the beat, walking down the street, and my new freak, yeah. This is how I roll, animal print pants out control. It's Red Bull with the big ass bra, and like Bruce Lee, where I got the clout, yeah. Girl, look at that body. Girl, look at that body. Girl, look at that body. I work out when I walk in the spot. This is what I see. Everybody stops and staring at me. I got passion in my pants and I ain't afraid to show it, show it, show it, show it. I'm sexy and I know it. I'm sexy and I know it.
Yeah, he's used to falling. Slide. So, my name is Limor. I'm Israeli originally, and I founded a company almost 8 years ago called RoboSavvy. The company is based in UK and specializes in robotics and especially in humanoid robots. I'm going to tell you a little bit about this little market industry. So, dancing robots. This is the band LMFAO who sing this original song, and humans are always fascinated with anything that can dance. Okay. Yeah. Anything that can dance, whether it is a dog or a robot, will always get viral on YouTube. And so the reason is because we are fascinated with this concept of the golem, of the machine that can do similar things to us, that we can control with no remorse. Doesn't have a pension plan that we can tell them what to do, and it's acceptable. And this is something that has been in the human consciousness for over 100 years. The idea of the robot, of the working slave or entity that is not human, that can do our job. So let me talk a little bit about how we actually designed the dance. We started by analyzing video clips of Beyonce and Michael Jackson, and discovered something interesting, that actually, in order to, what constitutes an interesting dance is not that intuitive. Typically, the nerd intuition for dancing means that you have to kind of, the whole body sticks to the beat, which we discovered is not the case. Different parts of the body can be with the beat or in dissonance with the beat. As long as some parts of the body are with the beat or multiple of the beat, it looks okay. And so therefore, this was the theme, and we then applied some software to design the dance. We split the music track into segments, and each segment had its own sequence of motions. There is a great difficulty in making humanoid robots dance. The reason is because they are inherently unstable. So a car is stable, you just leave it there, it doesn't fall, whereas a humanoid robot, if it doesn't think about what he's doing constantly, he will fall, as do we humans. So that's the main challenge, and that's why things are quite complicated, and it's the reason why it's a very popular research area. In fact, there are thousands of PhD students around the world researching this area, and there's very little to none commercial applications. This is a kind of a chicken and egg situation. If you're a PhD student, if you go and study robotics, you can make an impact because it's a clear slate. There is not much. Again?
On microphone changes.
So you can actually make an impact by studying that. And the inherent difficulty again is about stability or the lack of stability. That's why things are progressing slowly. Where humanoids robots are today, or what they can do, they can do different things. Like they can manipulate human objects. They can. There are some robot fighting competitions. They can climb stairs. They can interact with humans, and they can do a lot of things that humans can do. But it's all very academic. And so one of the most significant things that happened in humanoid robots was last year was a program launched by DARPA, by the Defense Agency. And they launched a program called the DARPA Grand Challenge. Basically, it is replacing of the soldiers with robotic entities. The challenge is about taking this robot from a contractor called Boston Dynamics and giving it to 6 groups, which are composed of academics and industry partners. And each of these groups, and this is his pet dog, each of these groups, they take the robot and they're supposed to achieve certain challenges during a period of about 1.5 years. There were several entities that have competed on the budget, so you get $1 million robot, plus you get a few $100,000 altogether. The program is about $20 million. The nice thing is that the outcome, the software developed during this program, the outcome is open source, so it can be used for other purposes. So if you look at this program, basically it represents the state of the art in humanoid robots. What are they supposed to do? This is the challenge. So this robot you just saw, he's supposed to drive a car and reach a certain point, and then get out of the car, open a door, traverse crawling in gravel, and then locate a pipe, climb a ladder, fix the pipe, do all kinds of human tasks. And the nice thing again is that the outcome is open source. So why is that important for outside of the military or outside of that scope? Because the main problem with humanoid robots is the cost. And the cost has to do with size. So let's say this robot is about $2,000. If you double the height, it will double the price. If you triple the height, it will go exponentially high to about $50,000, and if you go to human size, it's $1 million. And that has to do with the dynamics of how the system moves. But what if price was not an issue? And anybody would have access to humanoid robots that are as capable as the one maybe you will recognize. This was a project from Sony. There's another similar from Honda. These projects were $150 million in marketing budget, and they created very beautiful humanoid robots. But what if that was $1,000? So the answer is that this is going to happen pretty soon through 3D printing. 3D printing basically takes away the cost of mass production, of tooling, of manufacturing. And in such a robot, you have hundreds of little parts in each one. So the upfront cost of manufacturing is lower to zero. If you've got access to a 3D printer, which can range from the high precision Formlabs, or it can be some hobby kit for $400. If you can do it and you can make the parts, you're basically able to create a robot. So with my company, RoboSavvy, we're working on such a project, on designing a 3D printable humanoid robot that will cost the end user about $1,000, because you have to buy the electronics, you have to buy the batteries, you have to buy the cables, but you don't need to the actual structure of this skeleton will all be 3D printable, and so will the exterior shell. So the exterior shell will look like this. This is where we're at the moment in terms of prototyping. This is what it will look like, the shell. And it's a good example of how 3D printing basically can really make an impact on potentially a huge industry. We're planning also to launch a challenge, like the Grand Challenge of DARPA, but for non-military uses. So the challenge will involve shell design, or making the robot look like Iron Man or Barbie. Then motion design, to make him dance or do some moves, or traditional dancing, whatever. And then more sophisticated stuff like human-robot interaction. So, for example, it can be a tour guide in a museum, or it can have some social interaction, or net social interaction. We had a project we did with a humanoid robot that actually befriended you on Facebook when you met him. So that's basically the future. It's about robots. It's about making it accessible to mass market. Eventually, finding consumer killer apps, and also bringing younger generation into engineering and science, because everybody's fascinated by robotics.